Okay, so on this particular problem, we are simplifying. And so we want to make sure that we remember what simplify means. So simplify means that you should be combining like terms. So when we look at these problems, they aren't like terms. So like terms would mean the variable component and the exponent values would have to match exactly. So we're looking at these radicals. So in order for us to simplify to even determine whether they are like terms, we're going to need to break these down because they can break down. They can simplify further. So let's start with the square root of 20. So you should do a t-table, your tree diagram. So you break it down 4 times 5, 2 times 2. So the square root of 20 is 2 times 2 times 5. So what are we looking for? We're looking for a pair. So because there's two 2's, I pull a 2 out. The 5 stays in because he doesn't have a partner. All right. Then I'm looking at square root of 45. Remember, this 2 is outside. So it's 2 times the square root of 45. So we deal with the 45. So we want to identify and break it down into prime factors. So when we do that, we're looking at 2 3's and a 5. So that means a 3 is going to come out. Here's what you have to remember. This is 2 times. The 2 is a coefficient on the square root. So when I bring out my 3, it is going to multiply to the 2 that was already there. And then the square root of 5. Because you can only leave the radical if you have the correct number of partners with you to leave out. So a square root, you need 2 of the same number. A cube root, you would need 3 of the same number, right? So now we're just going to bring it down and simplify further. 2 times 3 would give us a 6. So when you look at the problem, when we want to identify whether we have like terms or not, we should look at everything behind the coefficient. So when we look at everything behind each coefficient, they match exactly. Square root of 5, square root of 5. So that means that our like terms, these are like terms because everything behind the coefficient matches exactly. So 2 plus 6 gives us an 8. And square root of 5 is just square root of 5. Okay? All right. Then on this one, we have square root of 27x minus 2 times the square root of 9x plus x square root of 72x. So we need to break each radical down separately. So 27. So it would be a 3 square root of 3x minus. So 9 is a perfect square. So that means that there's nothing left in the radical except the x because the 9, look, the pair of 3's leaves nobody left, plus x. So then we break down 72, 9 times 8, 3 times 3, 4 times 2, 2 times 2. So you have to break it down until it's all prime. So I have 2 sets of 3's, I have a 2 set of 2, I have that. So a 3 is going to come out, a 2 is going to come out, and the 2x has to stay in because he doesn't have anybody. So he stays. 3 gets to go, 2 gets to go because they both have pairs. So let's see what we end up with. 3 square root of 3x minus 6 square root of x plus 6x square root of 2x. So when you look at this problem, essentially what you're supposed to do is you're supposed to identify whether or not you have like terms because we're simplifying. So a problem is not completely simplified unless you combine all the like terms. So I look at everything behind each coefficient. Square root of 3x, square root of x, x square root of 2x. None of them have the exact same. So the end of this problem is here. That's the answer. It's over because you can't combine, but everything is simplified as much as possible, and then there's no more simplifying to be done because there are no like terms. Okay? All right. So try this problem for yourself. So I recommend that you pause and try to work it yourself, and then I'm going to do it. Okay, so on this problem, we have square root of 24 minus 3 square root of 54. So we should have broken down our 24 and ended up with a pair of 2's and a 2 times a 3. So we pull out a 2, and then the 2 times the 3 would have to stay inside, which would create a 6. And then on the second radical, we have 3 times the square root of 54. So we would break down 54 so that we could see who would come out. So 9 times 6, 3 times 3, 2 times 3. So a pair of 3s, so a 3 comes out. Remember, this 3 already was there. Then I pull out the 3 from the 54 and leave the 6 because the 2 and the 3 have to stay inside. So then we multiply. So 3 times 3 gives us a 9 square root of 6. So what do? We look to see, looking behind the coefficient, whether they are like terms. So both have square root of 6, square root of 6, which means they are like terms. So we just do 2 minus 9. So we should have negative 7 times the square root of 6. And that is adding and subtracting radicals.